Okay, so today we're going to talk about sequences and specifically arithmetic sequences. So far we have talked about sequences and we learned some function notation, something that would say like f of 2 equals 8, which would mean the second term was 8. All right, but today we're going to talk specifically about arithmetic sequences, which is a certain pattern, and it's defined by a pattern of addition and subtraction by a common difference. And this word common means that it's not just a pattern of addition and subtraction, but it has to be exactly the same addition and subtraction between successive terms. So like this first little pattern I have written here, for example, is plus 3, plus 3, plus 3. All right, so this one is arithmetic because you're adding a common difference of 3 every single time. All right, the next one, that one looks like minus 5, minus 5, minus 5. Even though it's subtraction, we kind of group addition and subtraction together, so that one's also going to be good. This last one, add 3, add 5, add 7, add 9. Now you may see the pattern there, because there is a pattern and you're adding odd numbers, but because the exact number that you're adding changes every single time, that is not going to be arithmetic. So it has to be the exact same every time. And then I just want us to remember explicit and recursive. So explicit was the formula where you could plug in. And remember, just like they all are, this is written like f of n. And recursive was the one that had the f of n minus 1. So the recursive formula had two parts. Usually it told me some starting value. So this is important for you to write down for what we're going to do today. So they somehow indicate a starting value. And they give me a formula that's f of n minus 1. And then we have some sort of pattern included here. And we talked a little bit on Friday. You all said it made more sense to almost think about the pattern instead of plugging stuff in. So hopefully that will help with how we're going to write some things today.
All right, so here's our first example. I am going to add one thing to the directions. It tells us to do explicit, but we are also going to practice writing a recursive rule for this scenario. And honestly, I think you're going to think that starting with recursive is easier than starting with explicit. So remember, recursive has my two parts. First, I need to say what I'm starting with and what I'm doing. So I notice that this sequence starts at 1 and is adding 12 every time. So to write that in recursive notation, I'm going to say it starts at 1, so the first term, not 1, 20. And then I'm going to be adding 12 every time. So we write that as f of n equals f of n minus 1 plus 12, because that's the pattern that I'm following each time. Now, the question is asking me to determine the value of f of 10 and tell what it represents. Well, you and I both know from today that counting all the way up to 10 is annoying. And 10 is not really that far away, but if it had said like find f of 100, you would have had to count all the way up from 1 to 100 to find your term, which would have been miserable. So we want to find another way to write this, and that's to use the explicit formula. Okay, so as we start talking about this explicit equation, I want you to notice a few things. First of all, you know this is arithmetic because we're adding the same amount every time. That you said was called a common difference, but I also hope that that stands out to you as being a constant rate because we're adding the same thing every time. And constant, first of all, rate, that word should make you think like the per or for each or for every. That should make you think that we're putting a rate with a variable when we write an equation. And also, things with a constant rate end up being linear. That means that my explicit equation is going to kind of mirror this y equals mx plus b form, okay, where we've got like the rate with the variable and the b is my starting point. Now, when we talk about this starting point, remember that starting point is normally a y-intercept, which is 0, y, right? Notice that that 0 would be like the 0 term here. And my equation doesn't give me a 0 term. So we have two options. Either you can count backwards to the 0 term, or we can write it in a different way. So let's do 1. 1 is where we will count backwards, because I think that will probably make the most sense with what you've done before. So if I count backwards, that's going to make, I'm going to subtract 12 because I'm going the other direction. That's going to mean my 0 term is 8. So one way to write this equation, or function rather, is to say f of n equals 12x, because that's the rate I have every time, plus 8, because that's where I'm starting. Or some of you like to write it the other way and you like to write 8 plus 12x. That works also. All right, now remember that is when you're starting with the 0 term here, or the y-intercept. Let's say that you want to start with the first term that they give you, which is 20, because that's how it's set up. So if you want it to match the recursive formula, you can do that, and that's fine. We're going to say, let me change colors here. We're going to say f of n equals, all right, I want to start with the 20, because that's where it's starting, plus, and I'm going to add 12 every time, but I'm not going to add 12 like the same number of times. It's kind of weird. I'm going to add it n minus 1 times, and we'll talk about why that is, but the quickest way for you to remember is that if you're given the first term, you have to do n minus 1, all right? If you were given, I'll just kind of tell you, if you were given the second term here, for instance, if this right here was a 32, you would be adding 12, you would make this n minus 2, because the second term minus 2. We'll dig into that together tomorrow, though. All right, so whichever function you've chosen to use, and I'll assume that you're going to do this first one, even though I could be really wrong. We're going to solve this problem, which says find what f of 10 is and tell what it represents. So f of 10, we want to use explicit. That's a lot easier, so we're going to plug in. So 12 times 10 plus 8. That's going to give me 120 plus 8, which is 128. So I'm going to write f of 10 equals 128. And then we want to interpret what that means in context. And I know that the 10, that was the number of hours, and the other one is the number of miles. So you should have a sentence that says something like, after 10 hours, Mila has traveled 128 miles from the store. So you just want to make sure that you explain what each of those numbers mean and give units. So make sure you have that sentence written in your notes. All right, so again, I'm just starting with recursive so that you see it just for practice. So the recursive here is going to be f of 1 equals 34, because that's my starting point. F of n equals f of n minus 1. And I want to see what's happening every time. So I'm going from 34 to 51 to 68 to 85. That means I'm adding, looks like 17 every time, so I'm going to put plus 17. That's just for practice. All right, let's do the explicit, because that's what we want to be able to solve this problem. So there's 2 explicit options, one that's going to start at 0 and one that's going to start at 1. So if we're going to start at 0, that's going to give me y, well, not y equals, I'm sorry, f of n equals. If I go backwards to 0 and I subtract 17, that's going to give me 0, 17. So that's going to say I'm starting at 17 and I am adding 17 each time. If I want to start at 1, I'm going to say f of n equals starting at 34, and I'm going to add 17 n minus 1 times, because 34 is the first term. Okay, so now we're going to use that to solve the problem. Find the height of the stack with 7 boxes. So we're going to do f of n equals. This time I'll show you how to plug in with this other equation, just in case that one makes more sense to you. 34 plus 17 times, this time, I'm sorry, I'm not doing f of n, I'm doing f of 7. So 7 minus 1, that's going to give me 34 plus 17 times 6. All right, that's 34 plus 102, which is going to give me 136. So the height of 7 boxes is 136 inches. So you want to make sure you have that sentence written. All right, one more example. All right, this time they don't give me a table or a graph. They do tell me in words what I need to know. So we have 3,400 frequent flyer miles for the first round trip. So I need to make a note that that's for the first round trip, and 1,200 miles for all additional round trips. So for all, that's kind of like the indicator that I've got a rate here. So just one more time, practicing recursive. f of 1 is going to equal 3,400, and f of n is going to equal f of n minus 1 plus 1,200. Okay, when we go to write explicit, this time I'm going to stay in that second format because it's a little harder to count forward and backwards when you don't have a table or a graph to look at. So I'm just going to say f of n equals, this is me starting with the first term. So since they're giving me the first, it's going to be 3,400 plus 1,200 n minus 1 because they're giving me the first term. Remember, this and the term number match up there. All right, and now we're just going to be able to solve and figure out how many does she have after 5 round trips. We're going to say f of 5 equals 3,400 plus 1,200 times 5 minus 1. That's 1,200 times 4, which is going to give me 3,400 plus 30, whoa, pretend I didn't say that, plus 4,800, which is 8,200. So that would mean after 5 round trips, she has 8,200 frequent flyer miles. All right, so hopefully you feel better about explicit and recursive rules for arithmetic sequences.